I'm not sure how many people are aware. We have Wienke from the Things Network, and if you've not checked the Kickstarter page, so I think as of last hour, the initiative is 100% funded. So without further ado, I give you Mr. Wienke of Things Network.
Cool. So, I'm Wienke. Finish this. I'm Wienke Giezeman from Amsterdam. I'm an internet entrepreneur. I don't know like how many people of you went to Amsterdam, but this is what it looks like. You know, we have water in the city, like canals. Do you see it? Or do you see the presentation?
We see the presentation.
Oh, I'm trying to show you the other one. Ah, yeah, here it is. Like,
yes,
it's autumn here in Amsterdam. So yeah, thank you very much for inviting me. I'll share it right now. So I'm gonna tell a story about a project we're doing, where we were able to create a Internet of Things data network in Amsterdam in 6 weeks. And 4 weeks later, we inspired a lot of cities around the world. And now, like just a few hours ago, we finished this Kickstarter. So my background is that I have a corporate background. I worked at PricewaterhouseCoopers. I worked at the Dutch incumbent telco provider. I worked at an ISP access role. I founded a video-on-demand company similar to Netflix, sold it to a big publisher in the Netherlands, and then last year I started a small IT company making Android and Apple apps. And when I sold my previous company, I was looking for like new trends, and one of the things I came across was the Internet of Things. And for me, Internet of Things was really a lot of like promise, a lot of gadgets, was not really like the promise of really making our lives better was not really there yet. And I was like, I bought this Apple Watch, which is also not it. And so like when I looked at Internet of Things, like I thought this is just stuff putting smart in front of things. So a smart fork, a smart cup, a smart toothbrush, and a smart X-ray. If you look at this one, what's interesting here is that these guys just went bankrupt, and I think they proved that nobody's really waiting for a smart X-ray. But one of the most interesting use cases I found was a little alarm, and this is a Budweiser alarm from the US. And what they made was this alarm, and it will ring when your favorite soccer team scores. So that this was what I thought a bit the state of Internet of Things. And if you look at the technologies that are currently used right now, that is mainly radio frequency technologies. I mean, the first step in connecting things to the internet without bothering them too much is removing the cable, because you want to connect things, but you don't want to leash them with the constraint of a cable. So there you had Wi-Fi. Wi-Fi is perfect for high bandwidth. You can stream Netflix over it. You can use it from your home. It has a free bandwidth, but it's really power consuming. So a lot of things still have to be connected to the power supply or have a really large battery. And if you look, for instance, Bluetooth Low Energy, you see that this is not really connecting things to the internet. It's connecting things to each other. And so, for instance, like if I have my Apple Watch, it connects to Bluetooth to my phone, but without my phone, it's nothing. So it unleashes my smartphone, but it also imposes a few constraints. And for instance, if you look at 3G or 4G, you see that this is a really expensive technology, also very power consuming. And if you look at the investments that have to be made to build a radio frequency network like this, you need large companies to make large investments. And so I had really the question, my question with the current state of Internet of Things was, where is this zero friction? Where is this promise that everything is connected to the Internet and can supply information to apps or to platforms that eventually can make your life better, predict what you like to predict your demand of the future, inform you of anything going on around your life. And when I ran into this technology, LoRa, a few months ago, in July, I saw that this was a technology that that allows to connect up to 10,000 devices. Within a range of 5 kilometers, and like this technology is really battery efficient, so your battery can last a really long time, and it has low bandwidth because things typically don't need high bandwidth, and the thing that intrigued me the most was the low cost of this network. So, for instance, if you look at this picture, this is a LoRaWAN gateway. It's similar to a Wi-Fi router that you connect to the internet, and then it becomes it connects your mobile devices to Wi-Fi. This uses LoRa, and the cost of this device is around €1,000, which, when I heard that, I had a picture in my mind. Okay, if I draw circles with a range of 5 kilometers, and I draw circles across Amsterdam, then you only need like 10 devices to create this network. And I thought, okay, so for €10,000 we can make a city covering network. That's like a fraction of the cost that it would cost you if you would do a Wi-Fi network across the city, or if you would do a 3G network. So then I thought, if the costs are so low, maybe this is even interesting if we just do this completely in a community and crowdsourced way. Because when I looked at how large corporations are using this technology, is that they invest in a network, and then of course they have to make money out of it. That's probably by subscription services, and therefore they need to place a gateway between the things internet and the regular internet, because you have to want to make money out of that, so we decided to do an open internet that doesn't have the gateway, because we crowdsourced the network ourselves, and then I presented this idea to my co-founder, because if you're just alone, you're just a lunatic, and he thought it was a crazy idea. I presented this at the Internet of Things meetup in Amsterdam. A day later, 10 of these people that were there were in the community, and we made a plan to create the network infrastructure, like the programming languages, of this network with this open source group. Then we needed to convince people in Amsterdam to crowdsource this, and then after 2 weeks, I found 10 10 people in Amsterdam, companies, individuals, like people that want to build use cases on this Internet of Things network, and they so they so that's so we were able to find all these people, and then this vision in my head of all these circles that was like reality. And when we told that we did this in Amsterdam, and we told it in the Internet of Things community worldwide, a lot of people around the world just picked up the idea and said, okay, we can build a community-owned Internet of Things data network. That is really awesome. So we got response from Buenos Aires, Sao Paulo, Kochi, in India, Sydney, Paris, London, and when we told the world that, we got even more response. So it was like we cannot even handle the response that people said. Okay, you're building this open source, open hardware network. But the one of the things we noticed is that a lot of we built this network with gateways costing €1,000, but for €1,000, that's still a lot. Like maybe for an Amsterdam internet company, it's not a lot, but still it's a lot. So that's why we decided to create the Things Gateway, which costs €200. It's a €200 gateway that can be installed inside, and it's also really easy to install. And what we also did is made 2 development devices: a node, which is like a sensor box, and the Things, which is an Arduino with a LoRaWAN chip on it. And yeah, we this is really otherwise I would have changed my slides because we just reached our goal of the Things Network, which is just really awesome. If you go to thingsnetwork.org and you go to the Kickstarter page, you see that we reached our 100%, and I think we're already surpassing it like crazy. Let me check where we're right now. Yeah, we're already way beyond 100%, and we're just going forward. And it's amazing to see how we, in 4 months we created this global movement of people that want to do this. So yeah, that's the story of the Things Network, and I would love to see maybe some guys here in the room talking to if you want to be initiator of Chennai. Yeah, feel free to contact me because this is going to be really awesome. And we're writing internet history here, and yeah, and that's where we are. And we don't know where we're heading yet, but we're really moving forward to our mission that we want to build a global, open, free Internet of Things data network. Thank you.
So yes, Wienke, can you hear me?
Yes.
Yeah. So we were actually once I saw the news in the hacker news site, I was really excited. Let's initiate for Chennai. So one of the things I was exchanging in the mail is that I got approval from the company to buy the node, but we still have this regulation in India that the frequencies that are listed is open in Europe and US. It's really hard to find if it's really open in India. So
it's hard to find what the regulation is.
Yeah. So
okay, that's awesome. I love this. I heard this around the world. There's these different problems and different hurdles, and this is really interesting. So I would love to hear the eventual results. I mean,
so we actually went to the Wireless and Planning Commission, the Ministry of Telecommunication, that's actually in Chennai.
Oh, cool. Oh, that's a coincidence.
Never respond any queries.
Yeah, so we had a contact, so we went there. Apparently, the Joint Chief Commissioner is the only one who can answer it, and he was not around. So we have another appointment next week. But I just want to say that if it's cleared, I think even if it is a licensed spectrum, the ask is once the gateway is in, we still need a clearance of the instrument type. That's a certificate which we can buy. The only I see is that if it is not licensed, then it's going to be really difficult. So I really don't know how this person started it in Cochin, because if it works in Cochin, it works in Chennai as well.
I will get you guys in touch.
Okay, that'll be awesome because I reached out in Twitter, but I couldn't get his handle. So
yeah. Okay, cool. So, any more questions for you guys?
I had a couple of questions. Yeah, Deepan.
Okay.
Okay, so just wanted to understand how this works a little bit in detail. So I was wondering all the internet.
Oh, you only here?
Okay. Able to hear me?
Yeah. Speak up, speak up. You can come here and talk.
Yeah. Okay. You're able to hear me now?
You should. Yeah.
Okay. So my question is related to how this works in terms of application. So if I have a device in my home which I would like to connect to this network and communicate to it from a remote area, you are talking about the range, long range. But my device should be able to communicate to the network, your node, isn't it? So, but most of the interface, the device that I can build on my device will not have this long-range communication, which can talk to your node, isn't it? How does it work?
Yeah, so this is LoRaWAN. It's like Wi-Fi, so the device needs a LoRaWAN chip. And the gateway needs a LoRaWAN chip. So if you want to build devices, you can buy these devices. They're being produced right now, all different kind of sensors, switches, whatever. And that's why we also supplied a LoRaWAN enabled Arduino, because you can prototype with that. So you need specific LoRaWAN devices for this.
Did you get it?
So okay, so if I can rephrase what Venkan said. So the gateway works like this, right? So on one end of the gateway, you switch the power and give either a 3G or your LAN connection. So gateway hooked down to the internet. From the gateway, the role of the gateway is that it has a Semtech chip in it, which is LoRa compliant. Yeah, and then it acts as a transmitter and a receiver, right? Why transmit? Because you need to transmit radio waves, which reach. So this being a radio, this being a radio wave, you don't need a line of sight, right? It can go past concrete. I believe.
No, and because it's
okay, yeah.
Because it's low frequency as well, it can travel through walls and etc.
Yeah, it can go through.
Yeah, so transmission is fine.
Yes.
So when or my device, my device, when it has to receive the transmission, if it is long range, I can actually receive it.
Yeah.
But when I have to send something back to the network, my device should be capable of sending the RF signals to a very long range. But most of the chips, RF chips, which are available, is like one kilometer. Okay. Not like 5 kilometers. What the nodes support.
Yeah. So the question is, Venkan, if your thing's node is, let's say, 10 kilometers away from the gateway, how does it have enough power to transmit radio packets that reach the gateway?
That's the LoRa protocol, and how that works on a technical level. That's not how far my knowledge goes, but it puts a signal on this in the Netherlands is 868 megahertz frequency, and then it travels there, and it's just radio frequency in that sense.
No. Even you misunderstood the question. So the question is not the transmission from the node to the gateway. It is from a device that I have at home to the node.
Okay, so nomenclature, right? So the gateway is your router router is also wrong. Gateway is the device that sends the packet. The thing node is the end device that you hold at hand, which is a dumb, small microchip, right? So as what I've read from the GitHub account, the benefit of or the advantage of a LoRa is that the end nodes, right, the small devices, the power requirement is really small. Now,
so that's the advantage.
Yeah. How does it have a range? I don't think I have an answer, but that's something we can dig in. Right?
So So in effect, maybe your device needs to be hooked up to that node somehow, and then the node is the one transmitting to the gateway.
Yeah, but the node is like 5 kilometers away, and most of the
But the
RF
node is
chips-
what is transmitting to 5 kilometers, right? It's not your device that needs to have.
There's
Right,
one
I think-
node.
yeah,
There's
so-
one node within the range of 5 kilometers,
It's just
and you have to talk to that one node.
yeah,
And
that
you
is
could
just
be-
okay. Let's use the word that we all understand: a device, right? A microprocessor, a microcontroller with some sensor. That's your device. Device can be 10 kilometers away from the gateway, but according to the spec, even if it is a low-powered device, based on LoRa's protocol and the way it is architected, you should have enough power to communicate to a gateway which is 10 kilometers away. How and why? I think we need to dig in.
Okay, thanks. I have to go, so unfortunately, because we just had the Kickstarter, there's a lot of press waiting for me. But you seem very knowledgeable, and I think you can also answer a lot of questions. I would love to hear from you guys if you're interested to set up a network in your city, and I would really love to learn from you. Like how can we make this work in India? That's I think that would be very valuable.
We'll keep you posted.
Yes. Thank you very much. Thank you very much for your time.
You too. Thank
Okay,
you.
bye. Thank you.